All right, this is lesson 333, variable systems in Algebra 2, and the goal is I can solve systems of equations in 3 variables instead of just 2. So I think there's kind of a process to these. Elimination is kind of the best method until we get into some upper level elementary algebra classes, which teach you how to use matrices to solve, let's say 7 by 7, 7 unknowns with 7 equations. You can use different methods there, but we're going to have to stick with elimination, all right? So the key is to examine the coefficients and try and find a variable that will be easiest to make opposites with. So if you look at this system I've got here, you notice there's a negative 7y, a negative 7y, and a positive 7y. So I think y is going to be easy to eliminate there, all right? If you notice the other ones, x is 7, 2, and negative 8, I would need to come up with multiples of 7 and 2 and 2 and 8. And for z, it'd be 9 and 1, and then 1 and 5. And so what we're going to do is we're going to use 2 of the 3 equations and eliminate the y. Then we have to use the unused equation and either of the other 2 that we used to eliminate the same variable again. So we're going to do step 2 twice. Okay, but you have to use all 3 equations. Okay, one equation gets used twice, all right, and the other 2 equations get used once, but you're always eliminating the same variable. So what you're creating is 2 new equations that contain the same 2 variables. So if we eliminate the y's twice, we're going to have 2 equations that have x and z. And then I just use elimination method like we know how to do for a 2 variable system, okay? And then you substitute values back into the original equation to find your different variables, okay? So let's see that in action over here. So this is that same system we were looking at before. Notice we have 3 equations and 3 unknowns. And I just want you to know that when you get into higher level mathematics, you have to have the same number of equations as you have unknowns, otherwise you can't solve the system. So if I have 4 unknowns, I need 4 equations. If I have 5 unknowns, I need 5 equations. If I have 6 unknowns, so on and so forth. And so you'll learn those as you go through some college mathematics, all right? So what I'm going to do is I'm going to number these equations because it's easier to talk about them if we number them, okay? So I'm going to take equation 1 and 2. Well, actually, I'm going to take equation 2 and 3 because the y's are already opposites. So I'm going to copy down equation 2 and I'm going to add it to equation 3. 2x minus 7y plus z equals negative 8. And then negative 8x plus 7y minus 5z equals negative 10. Well, they're ready for elimination. So 2x and negative 8x is negative 6x. And then 1z minus 5z is negative 4z. And then negative 8 and negative 10 make negative 18. So I'm going to call this one equation 4. All right. Now we're going to use equation 1 plus equation 3 because I already have opposites with y again. So I've got 7x minus 7y plus 9z equals 7, and then negative 8x plus 7y minus 5z equals negative 10. So if I combine those, again, those cancel. 7x minus 8x is negative 1x. 9z minus 5z is a positive 4z. And 7 minus 10 is negative 3, and that's going to be equation 5. Now we have a system with equation 4 and 5 that we're going to use to eliminate something. So I'm going to put equation 4 here and equation 5 here. So I got negative 6x minus 4z equals negative 18, and I have negative 1x plus 4z equals negative 3, and lo and behold, my z's are already opposites. I don't need to multiply by anything. I can go ahead and add these two together. I get negative 7z, those are gone, equals negative 21, and z is 3. Now you're going to go back to 6x minus 4z or 1x. You take either one of these, equation 4 or equation 5. Let's do equation 5. So if I take equation 5 here, sorry, that doesn't look much like a 5. There we go. 5. I'm going to go negative 1x plus 4 times 3, because that's z, equals negative 3. So negative 1x plus 12 equals negative 3, and negative 1x equals negative 15, and x is positive 15. Now take any of the original equations and plug a z and an x in. So I'm going to take equation 2 here. 2 times x minus 7y plus z equals negative 8. Well, that's 30. And then that's 33. Combining our like terms, 30 and 3. So subtracting 33 from negative 8 is, negative 33. Did I make a mistake somewhere? Or is this going to be a fractional value here? Let's double check. So z is 3, so I used equation 5, negative 1x plus 4 times 3 was 12 equals negative 3. And that's 12. And I subtract 12 from negative 3 is negative 15. Divide, I get a positive 15. So now 2 times 15 minus 7y plus c, which is 3, equals negative 8. 15, that's 30. 30 plus 3 is 33. So negative 8 minus 33 is negative 41. And if I divide, I get 41 over 7. Interesting. All right. Well, we're just going to go with it. Okay, so I've got 15, 41 over 7, and 3. And there's my solution right there. Okay? I still don't know if I like that. 7 minus 8 is negative 1. 9 times 5 is 4. 2 minus 8 is 6. 1 and negative 5 is negative 4. 6x negative 4z negative 18. Yeah, I mean, I don't see any mistakes, so we'll just give that a try there. All right, let's try example 2. Which variable would be easiest to eliminate, x, y, or z? Well, the x's are already like all just either 1 or negative 1, so it looks like maybe x terms, right? So let's number our equations here. And we're going to go with 1 and 3. I'll add 1 and 3 together. So negative x plus 3y plus 4z equals 1, and then 3 is x plus 7y plus 3z equals 0. Gone. 10y plus 7z equals 1. Now we'll do 2 and 3, right? Equation 2 plus equation 3, negative x plus y plus 4z equals 5. X plus 7y plus 3z equals 0. They're ready to add. 8y plus 7z equals 5. And so bringing those two down here now, this is equation 4 and equation 5. Well, if you look at them, they've both have 7z, so I'm going to do negative 1 times equation 4. And and then add equation 5 to it. Okay, so I'm going to negate all those. Negative 10y, negative 7z equals 1. No, negative 1, sorry. Negate everything, right? Good. And then copy down number 5, 8y plus 7z equals 5. Eliminate, I got negative 2y equals 4, and y would equal negative 2. So, plug negative 2 back in. I'll take this 8y, 8 times y, plus 7z equals 5. That's negative 16 plus 7z equals 5. Add 16 and divide, and we get z to be 3. And I'll take number 3, equation 3. X plus 7 times y plus 3 times z equals 0. So x plus, minus 14 plus 9 equals 0. X minus 5 equals 0. X equals 5. So you can plug them into any equation and they should work, right? I mean, that's the key to this, is you're finding values that make the equations true. So you can just plug them back in and get them, see that they work. Okay? Very stepwise, right? You guys want to give this one a try? Yeah, give this one a try. It's the last one. See if you can figure out the best thing to do. Stop the video, take some time, and I'll start it back up and show it to you. All right, so we got equation 1, 2, and 3. And I'm going to go with the y's here. So I'm going to take equation 1, and I'm going to add 3 times equation 3. All right, so equation 1 is 4x. I don't know why I said 3 times equation 3. That's not what I want. It's 10 times equation 3. There we go. That'll give me a negative, positive 10, excuse me. 1's got negative 10y, and then 3 will have positive 10y. So 4x minus 10y plus 9z equals 3. And then taking 10 times all the 3, we've got 30x plus 10y plus 70z equals negative 70. So 434x plus 79y equals negative 67. Okay, that's equation 4. All right, and now I'll do the same thing with 2 and 3. So I'll do 2 times 10, 2 plus 10 times 3. Add those together. So 3x minus 10y plus 8z equals 1. And then just copy this equation down there. 30x plus 10y plus 70z equals negative 70. This time the 10y's cancel. I have 60, no, not 60, 33x. I have 78z, and I got negative 69. So that's equation 5. So now what we can do on these is we can just crisscross, like, if you take 34 times 35, or 33, and you multiply each equation by that, you're going to have the same x term. So let's do 34 times 33. And so we're going to multiply one equation. So equation 4 is going to get multiplied by 33. And equation 5 is going to get multiplied by 34. Negative. One of them's got to be negative because they're both positive right now, okay? So we're going to get 33 times 34, which is 11/24. 22x plus 33 times 79 is 2607 y. Oh wait, that's z. Sorry, class. I put a y there instead of a z. There we go. So that's 2607z. And then negative 67 times 33 is negative 2211. So let me just double check those numbers here. So 34 times 33 is the 1122. And then 79 times 33 is the 2607. And then the 67 times 33 is the negative 2211. Okay, so now we're going to do 34. So 34 times 33, well, that's going to be the negative 1122x. And then 78 times negative 34 is negative 2652 z equals negative 69 times negative 34 is a positive 2346. Okay. So 2652 minus 2607 is going to give us a negative 45z. And then 2346 minus 2211 gives us a positive 135, and we divide by 45, negative, and we get negative 3. So there's z. Now let's figure out x. I'll take equation 4 here. 1122x plus 2607 times negative 3 equals negative 2211. So this is going to be 1122x minus 7821 equals negative 2211. I'm going to add that to the other side. So if I add 7821 to negative 2211, it's 5610, and I divide by 1122, and x is 5. This is looking good. And then let's just we'll take the last equation here. So 3 times x, so 3 times 15. So this is equation 3. 3 times 15 plus y plus 7 times negative 3 equals negative 7. So that's 45, and that's negative 21. And 45 minus 21 is 34. Plus y equals negative 7. You subtract 34, and you get negative 41 for y. So we got a 5, a negative 41, and a negative 3. Okay? I made a mistake there. 45 minus 21 is not 34. I believe 45 minus 21 is 24. And then subtract 24, you get negative 31. I think I caught that. There we go. It's really easy to make mistakes with these. One sign error and it's all over. So that's why I was so doubtful about that fractional answer on the first one there with that 41/7. I probably, if I work it again, I bet it works out to be something different, but I think I've got it right. So, all right, there's an assignment in Delta Math for you guys to try then.